So here's some typical Math 12, show me the exact value kind of questions. Okay. The sine of pi over 3, want to get the exact value. This could be straight off of a provincial. Okay. So what we're going to do is we want to just find, instead of all 6 ratios, we're going to ask the same questions. The reference angle is pi over 3. The quadrant is 1. So now we have enough information. It's going to be a positive, and it's going to be in quadrant 3. Or sorry, and it's pi over 3. So 60 degrees makes it root 3 over 2. And we would get an exact value here of positive root 3 over 2. Okay, so you try those next two and see what you can come up with for exact values. Okay, so this is a quadrant 2 angle. The reference is pi over 6. So for cosine, this was going to become a negative. So you could think of this is why we were practicing this. This is like the negative of the cosine of pi over 6. And pi over 6, or 30 degrees, is up here. So the cosine will be root 3 over 2. So this will be the negative root 3 over 2. Okay. So that was why we were practicing switching reference angles. So for this one, similarly, 9 pi over 4, this is quadrant 1. So it's going to be a positive. The reference is going to be pi over 4. Okay. And that means I could rewrite this as, well, no change in sign, but the cosecant of pi over 4. Pi over 4 is also known as 45 degrees. So here it is up here. If I want cosecant, what's the cosecant ratio? Remember, it was cho shakao. So you're looking for cho, right? Hypotenuse and opposite. So hypotenuse will be root 2, opposite is 1. So we could write this down instead as root 2 over 1. Okay, of course, the other thing that you can do is, if you want, you could write this down as the sine. You could think of it in your head like sine of pi over 4, which would be 1 over root 2. And then your final answer would be the reciprocal. Right? If you like working in sine because cosecant is new, that's okay. You can do that. But you just need to remember to take the reciprocal before you put your final answer down. Okay. So the last 3, I'll have you work on those. Again, you're working backwards this time. You're thinking of what value could I give me negative root 3 over 2. Now there may be more than one. So we'll talk about this in a minute, but I'll let you get started. Okay, so for the last 3 questions, when you work backwards, what you want to do is you want to ask yourself which of the tools that I use has the pieces I'm looking for. So what I mean is for root 3 over 2, we want to go up and look at the unit circle and the special triangles. Let me clean these up a little bit. They've gotten a little bit messy here. And we want to ask which of these tools that we use has the values I'm looking for. So for root 3 over 2, root 3 over 2 happens down here. I can see root 3 and I can see 2. So I know it must be in this triangle that I'll find my answer. So root 3 and 2. And it's the sine ratio. So the sine of 60 would be root 3 over 2. Okay, so that's my first clue. I know that my reference angle has to be 60 degrees. Okay, first clue, reference equals 60 degrees. And of course, we would like our answers in radians, so we're talking about pi over 3. Now, what we have to do is, we have to reconstruct where this angle could have come from. How do we know where it came from? Well, right here, it says it's negative. So we're going to draw a little picture. If it was negative, it has to be either this quadrant, quadrant 3, or quadrant 4. So in quadrant 3, that angle would become pi over 3 plus the pi over here, so it would be 4 pi over 3 together. And it looks like we're frozen. Give that a minute to work itself out. Okay, so now we're back in, this time if I'm here at pi, and I know the reference angle is pi over 3, that means one of my answers must be pi plus pi over 3, so I'm at 4 pi over 3. Same thing if I'm over here and my reference angle is pi over 3, that would make this side 5 pi over 3, so these would be my two answers. We'll skip the next one because the next one doesn't use a triangle, it uses the unit circle, just to show you again how this works. So these are the pieces, 1 and 2. My job is to go and find the triangle that they could have come from. So I look at the triangles in the unit circle, and what I see is, I see that this triangle here has the parts 1 and 2. So now if I'm cosine, I have to think which angle would I be? Well, cosine of 60 is 1/2. So again, I found the reference angle by looking on the out of the tools we use, unit circle, special triangles. So this one here, I know the reference equals pi over 3, or 60 degrees. And if it's a negative, now my picture will look like this. This angle or this angle. Somewhere in quadrants 2 and 3 if cosine was negative. So I know my references are pi over 3, and this is pi, so I can backtrack. This must be 2 pi over 3, one of my answers, and this must be 4 pi over 3. Okay? So in the last one, if we want to know where does the tangent equal to 0, well, we've encountered this kind of question before. Dealing with 0, this is like asking where does y over x equal 0 on the unit circle. So this is like saying where does y equal to 0. So if you take a look on your unit circle, that means I'm going to be at this position here when y coordinates equal to 0. So that would be either at 0 or at pi. So how did you know that it had to be unit circle, other than the fact that I just, yeah. It's okay? Okay. Other than the fact that I just said so, you look at your pieces here, you'll notice that none of those triangles have a 0 in them. So if none of the triangles can help you because there are no zeros, then we look over at the unit circle and we see, oh yeah, here's 2 zeros. One right there and one right there. So maybe this is the kind of thing I'm going to use to get my answer. Okay? So that's the end of exact values for us, but as I say, we're going to see this a lot and do lots of practice on it.